So welcome everybody. Sorry for the delay. What's that? Oh, okay. Thanks. So welcome everybody to 188 computer security course. So if you're in a different course, absolutely. But I mean, if you want to just hang out, that's okay too. So today I'm gonna just go through some of the basics, and if you have time, we go through some of the basics of the I mean some technical stuff as well, but mainly would be administrative. I have to also leave early a little bit today, so the class wouldn't be like full 2 hours, which is usually a good idea for the first class, since people don't feel like it. So let's actually, instead of like start with boring, like, here's the 10% lectures and so on, let me start with a story to give you maybe a little bit motivated of why we are learning about this. All right. So the story that I want to tell you is about this very famous and serious attacks called NotPetya, which happens in, I think, June 2017 in Ukraine. And given the circumstances that we are having now, it's actually quite interesting because it leads to also things that we are facing these days between Russia and Ukraine. So the story is, in sunny days, an employer of a tax company called Lena goes to her work. She opens her laptop as she always do, and she saw that there's this frozen message that your computer is hacked, everything is locked, and if you want to get your data back, you have to pay us 300 bitcoins. All right. She goes around and asks her colleagues, and then see that it's actually the same issue for all of them. So all of them are seeing the same message. And a few hours later, they actually see that this is actually a worldwide attack that not only impacted Ukraine, but also many other major countries, including Germany. The story is this attack called NotPetya. The reason it's called NotPetya is actually there was another earlier attack called Petya. And this was very similar to Petya, but it wasn't exactly Petya, so they call it NotPetya. And it's mainly infected Windows-based machines. That's another reason that you don't want to have a Windows machine generally, right? So, so that's the idea. So as I said, it happened in June 2017, infected many computers. According to some later reports with White House, $10 billion globally, it's actually impacted many economies. And mainly it was Ukraine. So the idea is that based on the reports, this was actually politically motivated by Russia. The part of the attack actually developed by NSA in US, but for some reason it's been leaked and Russia used it, and they actually targeted Ukrainian government. And as I said, the interesting thing is, if you follow the news this past few months, the starting of the attack of Russia to Ukraine, one of the very first things that happens in the first few days was also Russia actually impacted many of the industries through cyber attacks. So the attacks these days is no longer just tanks and missiles and aircraft, is actually also cybersecurity. So just give you a quick overview of how the attack works. Things that I'm going to discuss is actually, you're going to learn more about it later in the course. So the way this attack works is that it uses what is called a backdoor in order to enter the computer. We will talk about what is a backdoor. So the backdoor actually was part of a software that was for tax preparation. So things like, these days people are using for preparing their taxes. In Ukraine, there was this update to this tax preparation software that this update unfortunately has been leaky and there has some problems with it. So they actually use this backdoor in order to infect the computers. But usually these backdoors only infect one computer. In order for the malware or the virus to spread, you usually use another software called Worm. So the Worm is this software that's kind of like go through different computers in the same, for example, a company or different industry and so on. So it's kind of started from somewhere and then spread itself through a Worm. And then the actual payload, what is actually creating the damage, was what's called a ransomware. So the ransomware is this piece of software that overwrites everything and encrypt everything, all your files. So basically what happens was once the worms has enough spreading, then the payload becomes activated, and the payload basically what it does is goes through entire files of the computers and encrypt everything. And basically what it encrypts in a specific malware was it triggers a restart to the computer, and then basically it encrypts the payload for the bootloader, right? So NTFS is the file system being used by the Windows. What they did was actually they encrypt the entire file system. And instead of normally loading the windows, what's been shown was this message. I think I have it in the next slide. Yeah, this message which says your important files are encrypted. If you see this text, you have to pay us 300 worth of Bitcoin. Probably at that time, 2017, I think Bitcoin was already pretty expensive, but anyway. And then they have wallet ID and stuff like that. Once they pay, they're gonna send them the key. They can decrypt their files, and then they can just live their life. So the impact, as I said, it was around $10 billion economical impact in many different industries, specifically in Ukraine. But as I said, other countries in Europe also has been impacted. Very quickly, Windows issued some patches in order to fix the issue, but usually these things, unfortunately, are after the fact. We're actually going to talk about this in the course as well. But they issue some patches that at least future versions are immune against this type of attacks. But the main thing was that backdoor in that software, which quickly they patched that as well. So at least those computers that are not infected, they are safe. All right. So that's the story of what's called a NotPetya. And the reason that I told you this story is to understanding the impact of cybersecurity that we have these days. 10 years before, there wasn't this much interest and motivation about learning about cybersecurity. But these days, unfortunately, multiple reasons have forced people to actually get more and more information about cybersecurity. The first thing is because of the impact. So if you think about and look around your house and your everyday life, you see that you're surrounded by many computers. And these many computers don't work in isolation. They're usually connected to a bigger network, some sort of a WAN or LAN or some open internet, right? So it's basically virtually is open to any sort of attacks, 100 miles or 1,000 miles away from your system itself, right? So the number of devices is one of the critical things, but it's not just the number of devices, but it's also the critical applications that this device is usually used, right? So it's not like, yes, if you, for example, use your computer to listen to music, the worst thing that can happen is somebody hack into your computer and plays another song, right? So the one that you hate. But if you use your cell phone for example, checking your bank account, or maybe using your smart lock to lock your apartment, then if somebody hacks into your system, it means that things getting serious, right? So they can hack into your computer, they can steal your money, they can get into your building, and so on and so forth, right? And then at the state level, at the government level, this is even more serious, right? So all the important, defense systems using computers, all the important infrastructure using computers, and so on and so forth, right? So that's why the impact of cybersecurity is more important, and people are spending more time learning about this, and also spending lots of money on making sure that their system is secure, because the cost of, for example, being attacked is in orders of billions and trillions of dollars. All right. Any questions so far? All right. So that's the story of the impact. The second thing to think about is the difficulty. Unfortunately, because we kind of didn't care about security for a long time, we didn't design systems with security in mind, right? So what we did was kind of creating and thinking about how to minimize the cost, how to improve the performance, and how to make the device low power and smaller, right? What happened was because of this, we really didn't care about security, and the security becomes this very complex, multi-layer thing that now nobody's understand how it works, right? So we are kind of basically dealing with multiple layer of abstraction, the software, the operating system, the hardware, the interface between the hardware and software and so on and so forth, right? And it's very complex, each layer itself. So for example, if you look at the Linux operating system or Windows operating system, we're talking about a piece of software that has thousands lines of code. And good luck with finding vulnerabilities in this very complicated things, right? And it's not just that, it's actually layer by layer. Now, we're talking about very complex processor design. This also has many different modules, and we have no idea which part is secure and which part is not. And now these two are kind of combined together, and then the interface can also create new type of vulnerabilities, as we're going to talk about this in this course. So we are basically facing what is called a large attack surface. There are many different ways that the attacker can attack the systems. And unfortunately, the bad news is that they are doing it. So there are news every month or so that there is this new vulnerabilities at different sites. And the story of this course would be that we're going to go through different layers. We're going to start with like the system level, or go to the more embedded systems, operating system side of the things, and then go to the hardware and show you that this, at all of these different layers, we will see attacks that happen. But of course, we need to also think about the defenses, right? So what we can do, what is the best way of defending the systems, and also we're going to talk about, the future trends. Where are we going? And again, unfortunately, the bad news is that we're not going into the right direction. So things are going to get worse, and mainly because it's a very complicated problem to solve. And we've really been careless for a very long time. So it's not something that we can fix in like 5 years or 10 years. All right. Any questions? All right. So as I said, it's very hard area of research in general, cybersecurity, and it's also very hot demands because there's not much people who are expert in cybersecurity. So as someone who's kind of like trying to figure out your career, I think it's the right decision to at least know about cybersecurity and see if it's something that you want to pursue in your career. And what we're going to learn about, as I already said, we're going to learn about this cutting edge topics in system security and privacy. So our main idea is looking at the system level of things, how the interaction between different modules really happening. We're going to mainly emphasize the new paradigms of computing, basically the edge, cloud, the continuum between them, and the interaction between them, right? So more traditional security topics such as network, cryptography, or the operating system alone is not going to be covered in this course. This would be more of like, the initial course that some of you may have taken or some of you may not. So it's basically complementary to your CS136. I mean, again, if you have taken it, great. If you have not taken it, that's also not a problem, right? So generally, the prerequisite is thinking about you have some ideas about the computer organization in general, but since we're going to cover many different things in this course, you really won't be able to cover all the backgrounds. So we're actually going to give you some backgrounds, and you have some readings to catch up with. All right. Any questions? Yeah. What's that? Yes, I'm recording it as of now. Hopefully. Yeah. All right. Oh, so let me go through some course logistics, more boring stuff. So first of all, about me, this is the second year I'm at UCLA. This is a new course. So this is the first time I'm teaching this specific course. I've been teaching a graduate level course kind of similar to this, but this course specifically is the first time being taught. It's supposed to be taught last year, but different things happened, so we're teaching it this quarter. It's going to be offered again next winter. So those of you who are kind of in a waiting list, or there are friends who wants to take this course and cannot, you can take it next winter. But if you're graduating before next year and you really want to take it, I might be able to issue some PTs. My general research is around area of computer systems with emphasis in security and privacy. Mainly, I'm looking at the hardware side, right? Those of you who already know me, I have two cats. They're getting bigger and bigger. This one is named is Pino Jr. and this one is called Meadow, right? To pronounce my name, my first name is Nader. The R is longer. So, and then my last name is Sehat Bash, right? The good news is you can call me Sehat. You don't have to pronounce the second part. So you can call me either Dr. Sehat, Professor Sehat, just Professor, or just my first name. That's also fine too. You can call me Dr. Nader or Professor Nader. That doesn't make sense. Best way to contact me is through the direct message on CampusWire. I'm going to talk about what is CampusWire for those of you who don't know. But you can also email me if you have issues that's probably is not appropriate for direct messaging on CampusWire. The office hours usually by appointment. So just send me an email and we set up some time for you. But I'm usually in my office on Tuesday, 4 to 5, or even later. So if you want to drop by and ask questions, that should be fine too. My office is in Bolter Hall, way far from here. 6th floor, 6731, and it's a suite, so it's on the G room. Or we can also schedule it on Zoom. That's also fine. Right? We have a TA. Our TA's name is Shreyas. Let's put this picture here. He has a discussion session, I think, on Fridays morning, right? And he will have some office hours as well. I guess I don't know it at this time, but he will announce it on CampusWire. His email is here, but also similar to me, the best way to contact him would be through just direct messaging on CampusWire. All right, so let's talk about different course elements. The first thing is the lectures, and we have some paper readings and presentations, participation quizzes and projects. We don't have midterm, we don't have final, all right? And we don't have homeworks, basically. But your paper readings kind of like homeworks. So main things too, I want you to take away from this course, the philosophy that we have is we just want you to kind of like, cover a breadth of different things in computer system security. It's really, really wide area of research, many things, each of which could be a course by itself. Well, of course, we don't have time and we only have 10 weeks, right? So what we're going to do is kind of like, touch upon all these things. Some of them we'll talk more, some of them we'll just skip, and some of them will just give you some very basic overview, all right? So that would be the idea. Of course, we wanted to be very deep into the courses, but that's something that probably as we add more faculty in system security, we'll have more courses. So those of you interested to know more, probably take those courses down the line, all right? And as I said, given that we are we'll talk about multiple different things. We're going to talk about machine learning security and privacy. We're going to also talk about hardware security and privacy. And these are very different areas. And probably you might have some backgrounds in hardware, or you might have some backgrounds in machine learning, but probably not both. And what we're going to do is that we're going to give you some overview of those things. And hopefully that would be good enough for you to kind of cover the basics and understand the material. But also part of it, you have to kind of like, spend some more time on those areas that you don't have background. But the good thing is that I know that you won't have background. So I'm not expecting you to be master of those topics at the beginning, right? So the assumptions that what you know is very minimal, right? So don't be afraid. And then the other elements of the course, including the paper readings and the projects, is just give you some opportunity that go a little bit deeper on those topics that you are interested, all right? So you can maybe spend some time more reading a specific paper or doing a presentation on the topic that you want. So if you're interested more on the hardware side, we can present a paper on the hardware side. If you're more interested in the system or the algorithm level, you can do that, all right? And as I said, it's kind of almost the first time I'm offering. So as I said, many of these things already been taught in the graduate level course. It's available online. You can watch the videos, you can look at the lectures and so on. It would be some overlaps, but there would be some new things, right? So just a quick question. So I know that kind of class is divided between EE, CSE, CE, and CS. And surprisingly, we kind of have almost similar distribution among them. But how many of you have taken CS 136, the computer security course? Anyone? 1, 2. How many of you know what is cryptography? Like, have some ideas about like public key, private key, and stuff like that? Do you know mathematically or just heard about it? Like, okay. So like no course, like, going through the, the actual, like how many of you are, I guess those of you guys who've taken 136 know a little bit more, but others are just generally know what's cryptography is, right?
I think there's also cryptography class, although it's only offered once.
What's that?
I think there's also cryptography class.
There are multiple cryptography classes at the master's level, at the graduate level. I don't think.
An undergrad level.
Oh, it is?
But I think it's only offered once per year.
Oh.
It's really math heavy though.
Has any of you taken it? Oh, you're in it right now? Okay. Good. So we're gonna go in parallel. All right. Any questions so far, guys? All right. So as I kind of like said in the Canvas and on CampusFire, we're not going to use Canvas, right? So everything would be on CampusFire in terms of announcement and discussions and stuff like that. Most of the other things are just publicly available on our website. The address is our lab's website, github.io. This is the name of the course. This is the quarter that we are offering it. If you change this number to 209 AS and change this to winter 2020 or think spring 21, you will see the older version of the course that are taught in the graduate level. You can watch the videos, you can watch the lectures and stuff like that. As I said, there is no need to do that, but if you're interested to know more, you can do it. All right. I think most of you already enrolled on CampusFire, but if you didn't, here's the link for it, and here's the join code that you need to use, and do it as soon as possible, all right? Because we're gonna do the announcement and everything there. And then we're gonna use Gradescope for your quizzes and the projects and your paper readings. I think already all of you are enrolled, so I use Canvas to just link the roster with the Gradescope. But if you're not enrolled, send me a message and I'll enroll you. So formats would be in-person lectures, unless a new waves comes in and we have to all go to the misery of having the class over Zoom. All the lectures will be recorded. I'll post it on YouTube and put the links on the website. To find the lectures, this is the link you go to. There's a table. You see like lecture 1 video. You click on it. You go to the YouTube channel. You can even save that link. All of them will be posted on the same playlist. I'll try to have a good quality and post everything in 24 hours, but it's not guaranteed. So there is a non-zero chance that, for example, I forgot to put the microphone in or the camera in. So all of a sudden the lecture won't have any voice. It hasn't happened yet, knock on the wood, but it might happen. So if it happens, sorry. The best thing I can do is just going through the office hours and talk to you about that. But as I said, it didn't happen. I generally encourage you to come to the class, but if you don't feel like coming to the class, that's all right. The attendance is not mandatory, but it obviously is very encouraged. All right. The best way to have interaction is asking questions during the lectures. So just feel free to raise your hand and ask questions whenever you have. And another thing that we usually do a lot, and I really want you to follow that, is posting questions on CampusFire. So even if you asked something in the class wasn't clear, or you didn't have a chance to ask it, or you didn't come to the class and watch the lectures later and wants to ask something, the best thing to do is just posting it on CampusFire, and people will see it when people will answer. All right. And then obviously we're going to use COVID-19 guidelines for UCLA. I think at this time everybody has to wear a mask. I think I don't have to, but I'm just going to wear it until they tell us that everybody can just take it off. All right. And then if they tell us to not wear it, we not wear it. Whatever they tell us, we're gonna just follow those guidelines. Syllabus would be, as I said, very diverse from systems all the way to hardware. You can find it here in this link. I still will probably make some small changes. So I think the current syllabus is a little bit wider than what we're gonna actually cover in the course. But we're gonna probably just, as I said, touch upon all those things. So another important part of the course is the paper readings. Starting from next week, I'm gonna post a list of 3, 4, or 5 papers. What you need to do is only read 2 of them at your choice, and you're gonna post a review for it, which I'm gonna talk about. So you just pick 2 of those papers on for your choice, based on your choice, and then you're gonna write a review for it each week. All right, and we're gonna continue this all the way to week 10, but nothing for this week. All right. And the idea of the papers is basically just giving you a little bit more context and a little bit more details about the things that we discuss in the course. So specific topic in that lectures that we talk about is going to be those courses. The papers are usually very high-end and influential papers, either very recently been published or has been around for some time, and we selected it for you. All right. So as I said, paper review. So you have to submit 1 page, not more, of review for 2 papers each week. I already put a template of what your review should look like. It's actually, it has to have like 4 or 5 sections. You have to give one paragraph of what is the paper is about, what are the weaknesses and stuff like that. One question that most people always ask is that how to approach these papers, how to read papers. I think this links for this paper that's published with one of my colleagues at University of Waterloo is a really good approach of reading papers and approaching papers. They use what is called a 3-step or 3-phase approach. So just skimming through the papers, going to the details more and more. And as I said, the goal is if you're interested in that topic, spend more time on that paper. If you're not that much interested in that topic, maybe just read it so that you can write that 1-page review. All right, so that's the idea. So it's okay if you just skip some of the papers, but I really want you to spend some time on some of the papers and really read through them thoroughly. All right. As I said, the template is already in here in this Google Doc. So in order to submit your reviews, we usually have the deadline just 5 minutes before the class on Thursdays. So we're gonna usually publish the list of papers for next week's on Thursday on Friday. You have 1 week to read those 2 papers, and you have to submit your reviews on the next Thursday, just 5 minutes before the class. You have to submit it on Gradescope. The way that we're gonna do it is we're gonna label the paper saying, okay, this is like paper number 1, 2, 3, so on. And then on Gradescope, you will see the same labels. Just make sure that you submit your reviews individually and separately into those links. And of course, since we probably publish 4 papers and you're gonna submit only 2, you pick those 2 and then submit. All right, any questions?
Sorry, is it 1 page for each paper?
1 page for each paper, yes.
So like 2 pages every.
2 pages. But that's your only homework, basically. I mean, generally, I think in terms of workload, this would be much less than your normal course. This is more of a graduate level feeling course. It's not an undergrad fundamental course, all right? So that's why you do paper reading and stuff like that you normally won't do in an undergrad course. And this is by design. I want you to actually expose you a little bit to what the graduate level courses will feel like. I'm sure that most of you already taken graduate courses anyway. All right, presentation. So what we're gonna do is that those 3 papers, usually we post 3 papers. A group of 2 each week, we're gonna present those 3 papers. So each group gonna present 1 paper. And I think we have about 50 people in the class. So probably what will happen is that every group will present 1 paper. So we're gonna have around 25 papers in the entire quarter. The presentations would be on Thursdays, 20 minutes at most each. So what we're gonna have is each week, we're gonna have 3 hours of lectures by me and 1 hour paper presentation by you. That would be the rough design of the course. I will send you the details of the papers and how to sign up for paper presentation and stuff like that. For teammates, either you can pick your own teammates or I will assign you a teammates. Either of those can work. All right. If you really want to be alone and presenting alone, that should be an option too. But I generally, recommend having some sort of a group team members as well, because you kind of reduce your workload. Also, you get to know somebody and you can collaborate with somebody. Questions? All right, so the goal of the presentation is going a little bit deeper into that paper. Remember, some of you have already read that paper, some of you won't, right? So you need to kind of teach the concepts to those people who haven't read it. And also you need to kind of give a different perspective to those of you who have already read, right? So that's the idea. And just because of that, just don't mention everything already mentioned in the paper, your perspective, what you have learned from this paper. All right, so describe things in your own words rather than describing things on the paper. All right, and you will be graded based off your presentation. So good presentations do count. If you do a terrible job on presenting, you will lose some points. And then the important thing is that since this is 1 hour of the 4-hour lecture, if you do a poor job, it basically impacts everybody, right? So boring presentations for 1 hour is just, we are wasting 1 hour of the class listening to something very boring, right? So be a good citizen and spend some time on your presentation. Everybody else would be also motivated and all of you will be benefited from, right? And it's also a good practice for you, because lots of your job, both either as a graduate student or if you join an industry, would be presentation. So it's not just all about technicals, it would be also about presentation. So it's important to you be able to communicate at a very deep technical level, but something that everybody would understand. So using good visuals, CAD memes is highly recommended, but just generally use something that's engaging and interesting, all right? Questions? All right, so kind of guideline for you for the presentations. As I said, 15 to 20 minutes is the good number, good size for your presentation. Don't go over 20 minutes. If you go over 20 minutes, I'm gonna stop you. I'm gonna deduct points, unfortunately. All right, so 20 minutes is your hard deadline. Usually the idea would be try to have at least 2-3 minutes buffer, because things can last a little bit longer. You might get excited and start describing things a little bit more. So I would probably, what I would do is shoot for 15 minutes, and if things get a little bit longer, that should be yours. All right. And things that you need to do. So you can always go back to this when you're doing your presentation. Well, just let me quickly go through this bullet points. So skip any sort of motivation or introduction. Don't start with yeah, cybersecurity is important. I already gave you that lecture. All right, so everybody in this class now knows that cybersecurity is important, privacy is important, all these other things, right? So don't start with very basic, boring things that everybody starts in their papers. Just go through the very first slide should be the problem this paper is trying to solve, okay? Very technical. This is the problem. This is what their approach is. All right, and then the next few slides should be some sort of a background. All right, so here's the background of this idea. Here's the papers that have been done and things that have been proposed before this paper. And here's what the paper is trying to present. All right, and again, you kind of try to little bit, teach people of what's going on. Don't just, read things through the paper and say, okay, this paper is doing this, and here's the results and things like that, right? So bring it more as a practice for teaching somebody the specific topic that they don't know. All right, questions? All right, then you describe the solutions and the contribution, again, try to provide intuition. Like at the high level, this is why this works. We don't care about, oh, this pin goes there, and this is like, 10 bits of data going there and there. Details is not that important for us. The intuition is what really we're gonna remember from this course and from this paper, all right? And then give us some evaluation methodology and results, but that has to be short unless there's some interesting insight from them, all right? So just, again, don't put all the tables and say, okay, this is one result, this is the other results. People can read the papers and think about them. If there's anything interesting from that, just tell us that. All right, and then the final thing is very important is that your final slide should be kind of like points about the paper. So here's the weaknesses, here are the discussion points. I really like this or I didn't like that. So it kind of engage some discussion in the course on campus wire. All right, so what we are looking for is just, in addition to learning about what the paper has done, we want to also have some sort of, healthy discussions around that paper. All right. Questions so far? Maybe have a 2 minutes break. Which too long?
Yeah,
Is this class replaced?
No. Yeah, it's for the undergrads. Good. So the grad version has like original research, a little bit more paper heavy, less lectures, less exams. This is like very open-ended kind of course. So grads can take this course as well if they want to.
Can they petition, like, can't grads petition and take it?
Yeah, they can. Yeah. Usually one course counted through the grad. You can take one undergrad course in your grad.
How are you doing?
Good. How are you?
Played now since what, December? Right?
Yeah,
Yeah, I was winter for you.
it was fine. Yeah.
You were taking the 209?
Yes.
The 298 or something else?
209.
Yeah. Is that the only thing you're taking?
Yeah, usually it's just one course per quarter. So the load is not more than that.
Yeah. Winter was nice. All right.
I think winter went so quickly because of the first month was like online and then so people kind of like came back to the campus and
And then
then
it's like midterm.
yeah, it's already midterm.
And then it's half the-
Let's continue. So participation is, as I said, coming to the class is not mandatory. I'm not gonna grade you based off that, but I'm gonna grade you based off your general participation on campus wire or if I just remember your face in the class. All right. Mainly the easiest way for us to track your participation is your reputation points on campus wire. So those of you who are already familiar with campus wire will see that there's a tiny little number next to your name. And if you post things or answer each other's questions and things like that, that point goes up. And for now, you're thinking about like everybody should at least get 30 points. Usually, very easily, everybody get that. So try to at least by the end of the quarter get to that point. And you get that too by asking questions or answering each other's questions. All right. And probably in the last week, if you don't have enough points, you can ask random questions. Or I've seen in the past that people answer their own questions because by answering questions, they're like, so you can do that too. But I mean, what's that?
The points don't go up in that case.
It doesn't?
If you ask a question and answer it yourself, you only get the points for asking the question.
Oh, really? Oh, I didn't know that. Okay, so that doesn't work, guys. That's not a good hack. But the best thing is asking your friends to post a question and then you answer it. That's yeah, that could be a good. But yeah, you can do all these tricks. But generally, the idea is that having a healthy discussions in campus, right? All right. I'm not gonna like, if you're 29, I'm not gonna deduct points. But generally, if I see that everybody is active, I'm gonna give points to everybody. All right. Again, I'm not very stingy on giving points. The goal is like everybody hopefully get an A. As long as I see that everybody's kind of learning. So, all right. So yeah, you can ask questions about the concept in the lecture, about the papers, about presentations, anything interesting from the outside world that is relevant to this course, because generally cybersecurity is something that's, exists in pop culture, stuff like that. So any interesting news article you've seen, any relevant news to the course, you can always post it there. That's also part of the material. All right. This camera is not tracking me well. All right. So that's the participation quizzes. We're probably going to have 3, or we might have 2. It really depends. We're probably going to have it in week 3, 7, and 10. The quiz is not cumulative, so it will be just based off that 3 weeks worth of class. It will be based on the lectures and the papers that we're going to read. It will be open book, open note, and the quizzes will be just basically very basic sanity check of you have read the papers and you have watched the lectures, right? It will be just yes, no questions, multiple choice questions, basic, very basic and simple questions. It's not going to be you have to drive Chinese theorem for cryptography algorithm. It's not going to be like that, right? So the course is really, as I said, we're going to stay at the intuition and concepts rather than going to the details. Probably the exams would be on Friday afternoon. We will give you like a 4 to 6 hour time window, but you will have 1 hour to take it. So there will be time 1 hour, but you can start it somewhere in that window. If you cannot make it in week 3, 7, and 10 on Fridays, just email me or send me a note on CampusWire, and we can find another time for you to take the exam. Course projects would be probably 2. Still haven't finalized the courses, but probably one would be on some sort of a capture the flag, or some sort of machine learning, security, and privacy, and the other one would be on malware analysis. The project would be probably simple and basic, so just helps you to understand the concept. It might involve some sort of basic programming, either C or C++ or Python. It's usually your choice, but it wouldn't be like a programming heavy type of project. And projects would be light. Again, compared to your regular CS course, it would be much more light. All right. And compared to the computer architecture course that I taught, and so most of you have taken, it would be lighter than that. All right. And another option is that if you want to do an original research, you can substitute your 2 projects with an original research. But I'm guessing that would be a very tiny number of you that wants to do something as an original research. But that's an option too. If you want to do that, you have to contact me and we have to talk about it. Okay, grading. Grading would be 20% reviews, 20% paper presentation, 25% projects, 30% quizzes, 5% participation. Hopefully 300, right? Yeah, it is. And then there will be 5% bonus on participation on the project and on the presentation. If you do a really good job on presentation, I'll give you 5% more. For the presentation, I'm not gonna do, how much is the presentation? 20. I'm not gonna do 19% because I didn't like that one slide. So it would be mainly either 0, 10, or 20, right? So it's more of like these 3 numbers. So if you do a good job, almost a good job, you get that 20%. If I see you didn't really care, you get probably 10%. If you don't do it well at all, that would be 0%. All right. And the reviews would be just for the completeness. So we're not going to actually go through your reviews. We're going to just making sure that it actually makes sense. So reviews may be just 0 and 1 based on your grade. All right. Class participation, you already know. Quizzes is quizzes. Projects and quizzes is easy to grade, right? So that would be the game. Any questions? So we do absolute grading. So you can just compute your own grade. 96 to 100, 90 to 96, 85 to 90, and so on and so forth. If I see that some of these are very difficult, I might scale it up. Nothing's going to be scaled down. So you might actually only be helped and get better grades. So for example, if the quiz all of a sudden becomes so difficult, which is the chances is almost zero. I might actually scale it up so more people get better grades, right? But I'm assuming most of you will get some form of 90%, right? So usually like 80% or so, I'm hoping get 90. Any questions here? So there is no reference books because we're kind of like covering a wide, materials. There are some introduction to security books that would be useful. I'll post some of them on CampusWire, but generally it's not required and wouldn't be that much relevant to most of the things. The best thing is reading those papers and just watching the lectures, all right? If you need more, the best thing is usually go through the papers more, like more other papers. The discussion sessions, as I said, would be on Fridays. Discussion sessions won't be recorded, mainly because the TA is just difficult for the TA to record and make sure that it has engaging discussion sessions, all right? The discussion sessions won't be recorded. What we might be able to hand out the notes afterwards, all right? But that's also at the discretion of the TA, so whatever he prefers to do. We might need to actually send you some media release because I'm going to post this to the open internet on YouTube. So just, if your face, for example, is on the video, you're fine with it. That's all. And of course, the academic honesty is the important thing. So any sort of, cheating during the quizzes or the projects will be reported to the student first. So make sure that you just, generally, as I said, I'm not asking too much. So hopefully you just follow it. I think that I've seen in the past is reviews, people just copy paste things from the paper. Don't do it, just rewrite things. There are also tools these days that you can put the sentence and it will rewrite it for you. So if you're too lazy, and also don't copy it from your friends, right? So don't get the paragraphs and copy and paste. Spend some time, 30 minutes or so, you can usually catch up what the paper is about. Okay, any questions? All right, that's all with the logistics. So we have around, so as I said, I'm gonna end this class a little bit earlier today, maybe at around 11, 20, 25. But then next class, we have like a full-on class, okay? All right, so let's now talk about some of the fundamentals about security. So first of all, what is computer security, right? What do you call a computer secure? What is secure and what is not secure? And anybody has any comments on this? What do you think is a secure? What do you define as a secure computer?
A computer that allows authorized users to perform authorized actions and doesn't allow anything else.
Cool. So you're only allowed to do things that you're authorized. Any other things? That's a fairly accurate explanation. So basically, we're saying that achieving 188. Okay, sorry. So we're trying to achieve some property despite the presence of adversaries. So the key thing is we're not assuming that everything is good and nobody's trying to hack into our system. The assumption is that there is an active adversary, but we still manage to achieve those properties that we want, right? So we are saying that, for example, Nina, as a person, a user of this computer, can only read this file. And we are assuming there are hundreds of other people trying to also read that file. And our system should be able to prevent the access of that file to those persons. So authorization to the person or persons that are allowed to use it in the presence of the adversary. All right, so we call that security. We're trying to achieve three main goals in security. We usually call it CIA. Interestingly, it's confidentiality, integrity, and availability. All right. So the confidentiality means that only those people who are supposed to read specific content, they should be allowed to read that content. All right. So that's what we call as confidential. The integrity means that if you're moving or storing data, that storage, so during different times, if you read or access that data hasn't been, should not been changed. All right. So it should stay the same as the original writer writes it. Okay, so for example, if you send message to another user, let's say Alice sends it to Bob. What Bob should receive is the same message as the Alice intended. If there's any other message, we said that this is not, the integrity has been violated. Or if we store some data in our memory, we write it, and some later time we read it. If these two are not similar to each other, we said that the integrity is violated, right? So usually integrity is when we're communicating something or storing something, and the idea is that whatever we have stored or whatever we have sent, that's the same thing we should have received. Otherwise, this is a violation in integrity. Just keep in mind that confidentiality says the content, integrity says just the difference, all right? So you may not still, so as an attacker, you still may not know what you are sending, but you might just send something different. And that's an integrity problem, all right? So that's the idea. And finally, the availability means that the device, the computing device in this case, because we're talking about the cybersecurity issue, should be able to provide the service that it does. And there are lots of attacks, usually what's called a denial of service attacks, or DOS. These attacks, that their targets the availability. So the idea is that the server goes down, I don't know, the ATM machine goes down, the autonomous car doesn't work, and things like that. So the idea is just, destructing something in some way. They're not trying to change the content, or they're not trying to understand what the content is. The only thing that they're trying to do as an adversary is making sure that the system doesn't work. And that usually has also a huge amount of ramification, right? So there's lots of problems that come with it. So for example, if the servers of AWS goes down or the Facebook goes down, that's a huge loss to that company. So that's why attackers are interested to attacking those systems. But for example, in military systems, that's also very important, right? The availability of missile detection systems. If we manage to disable that, then we can attack, right? So these are the more important things that we usually care about. Right? So confidentiality, integrity, and availability. These are the main three things that we really care about. Any questions? So in addition to that, there's 5 other metrics that kind of really not security, but it's kind of very similar. One is privacy, that we're going to talk about this in this course. When we're going to talk about privacy, we'll see what is the actual definition for it. It's kind of similar to confidentiality, but it's slightly different. So people all often confuse confidentiality with privacy, but they're not really the same thing. Authentication is usually, as it's kind of a basic block for many of these things. So authentication means that making sure the ID of the person or the user or the machine or the block or whatever is the same that they're saying they are, right? And then just checking that whether that entity is allowed or authorized to access that specific service. All right, so that's the authentication. Then we have 3 things that they're not really security. It's more of a safety or fairness. All right. So reliability is generally a safety issue. So for example, for reliability, the difference is we are not in an adversarial settings, but we are in a environmental settings that is not necessarily a friendly setting. So for example, the temperatures change rapidly. There's lots of alpha particles that, there's soft errors and things like that. So in this case, reliability, basically the adversary is the environment in some sense. But this is more of unintentional, right? So it's not an active adversary. It's a passive adversary in some sense, and that is the environment. Right? So that's the difference between really the reliability and security issues. So you want to make sure that your system works regardless of changes in pressure, regardless of changing in temperature, regardless of changing in other environmental things. And that's a reliability issue. It's not a security issue. All right? And then fairness and explainability is also one of those 2 new metrics and concepts that's coming out, especially in the area of AI and machine learning. And the idea is that you want to make a decision that is kind of fair and it's not biased, right? Again, this is kind of relevant to security in some sense, but it's not exactly that, right? So you want to make sure that whatever decision that you're making or whatever algorithm that you have is fair. And also you want to make sure that you can explain what you made, why you made that decision. And these are, again, important in terms of security of the systems, but it's not exactly security. So we're not really going to talk about these things. We're going to talk a little bit about privacy and authentication in this course as well. But the three main things that we're going to focus is would be confidentiality, integrity, and availability. All right. Any questions? Am I recording? Okay. So how to achieve security? All right. So in order to achieve security, it's kind of like step-by-step approach we need to take. The first thing we need to do is defining some policies in order to achieve that security goal. All right. So usually computer security is based off just list of long policies that we have to follow. For example, we say, okay, remember we said only Nina has to access each file. How do we enforce that? We're gonna use password protection, for example. And we're gonna tell Nina what the password is. And in that case, only Nina can access that. But of course, there's another policy for how to distribute the password, how to make sure that the password is secure, how to make sure that the password is selected in a way that is secure, and all those things. So that's where the implementation and the enforcement also comes into the play. So we want to do a password protection file, but how do we exactly do that? That's a computer system, that's a software for itself. And the implementation can be challenging. And unfortunately, as we're going to talk a lot in this course, you will see that the policy itself is not an issue really, but the implementation is actually the source of the bug, is source of the backdoor. And the reason for that is, again, because security is a very hard problem, it's a very complex problem. And as a result, implementing something, for example, in the operating system is a very challenging task to do. And that's where, unfortunately, the backdoors and bugs and things like that happens. And the second thing is the enforcement. So sometimes the enforcement is also a challenge. Once we go through more topics in the course, you will see these examples of both of these things in the course. All right. And then finally, I mean, of course, we have to have things secure by design. We hope to make sure that the attack doesn't happen. But in real world, that's not the case. Always attacks happens. So on top of achieving security, we also need to provide mechanism for detection and reaction to the security breach or problems or attacks. So there are lots of methods on detection, for example, malware detections, attack detections. There's also lots of works on predicting and reacting to the attacks as well. All right, so later on in the course, especially when we are talking about malware detection, we're going to talk a little bit about these things as well. So it's not just about, okay, how to make the system secure, but it's also how to detect that an attack is happening and how we can prevent it. Because unlike normal, for example, attacks that you can see that something has been broken or something has been stolen, you may have no idea that, for example, your webcam is being abused or your file is being stolen and so on, right? So we need the methods for being able to detect that as well. So how do we define security policies? Like, what is the correct way of defining all these policies? In order to define these policies, we need to follow some principles, all right? So again, it's a tier approach. We need policies. For policies, we need what's called a principles, right? So in the next few slides, I'm going to talk about the main security principles. And these principles are not really a hard theory or based off some mathematical equations. It's based off mainly some intuition, right? And just years and years of experience of people in the cybersecurity domain, all right? So let's see what they are. The first thing is what's called a threat model, all right? So in order to make a system that is secure, the first thing that you need to understand very well and define very well is a threat model. And by threat model, we basically thinking about two main questions. One is what are the attacker's capabilities, right? Can the attacker, for example, have a physical access to the computer that I'm using? Or how long would that access be? Or what is the attacker trying to achieve and so on, right? So the attacker's capability is one of the key things that we need to very well define and assume. And these things are usually just assumptions. So you might think that, okay, the attacker cannot have physical access to my system, but all of a sudden the attacker, one way or another, has access to the system. So these are assumptions, can may be true, maybe not be true. So you have to be very careful. And then the other thing is on the defense side, what are our capabilities and what are the weaknesses, right? What are the challenging things that we need to be worried about? And what are the things that kind of be figured out and we have to be, we are kind of like feel good about it, right? So to give you a little bit more detail on the attacker side, the kind of like the four main questions that we usually ask is what the attacker knows already. So what are the inputs for the attacker? For example, we usually talk about white box, gray box, and black box attacks model. The white box means that the attacker has general knowledge about everything within the system, except that key or secret that the attacker doesn't know. Are we good?
Yeah, sorry about that.
So the attacker knows many things about the systems, except that's very content that the attacker tries to achieve, right? The second thing is the level of access of the attacker, whether it has, as I said, physical access, for example, whether the attacker can look into my computer, maybe type things or not. And then another thing is the temporal access, how much time the attacker has in order to attack the system. So for example, maybe there is a visitor that comes into this room, but only will be here for like less than a minute, right? So what the attacker can achieve in less than a minute versus another attacker that can come here and just be here for an hour, right? So there are two different things that the attacker can do in those two scenarios. And then the third thing is the privilege level. The privilege, as we're going to talk, is mainly a concept in the operating system, where we essentially say some of the users have more access to more things in the systems versus some of them has less access. The privilege can also be a physical privilege. For example, somebody who has access to some part of the building, but not the other part of the building, and things like that, or more equipments they has, and things like that, right? So that's the second part, the level of the access. The third part is what the attacker trying to achieve. What is exactly the attacker wants to do? Is it a confidentiality problem? Is it an integrity problem? Or is it an availability problem? Or is it a combination of all of these or some of these or whatever? So that's another thing that we kind of need to be worried about, right? And finally, what are the attacker's resources, right? So whether the attacker comes with a like very powerful GPU, or for example, whether the attacker is coming with a very basic antenna to record things, or maybe a very tiny voice recorder, or maybe the attacker coming with a suitcase with lots of equipment. And as we're going to talk about in this course, you will see that there's a huge difference between these things depending on the threat level and the attack scenario. All right, so the attacker resources is also another thing that we need to think about. And again, these are the assumptions that we have. Again, it's not something that we can prove that the attacker cannot, for example, do this or do that. But usually we're going to say that our system is secure under this assumption. So for example, we're saying that if the attacker cannot have physical access to our system is secure. Of course, if the attacker do have physical access to our system, the system is no longer secure. But again, our assumption is that maybe we're going to hire some guards, maybe we're going to put some good locks in this door, so the attacker cannot really come into this room, right? And this way, we're going to prove that our system is secure. Any questions here? All right, on the user or victim side, again, kind of like the reverse of what we already asked. The first thing is what needs to be protected, and level of existing protection is also another question. And the third thing is that we're going to extensively talk about in this course is what can be trusted. And as we're going to talk about, we're going to see that usually in computer systems, we're going to start with trust from the hardware. We're going to say that the hardware has been manufactured correctly and nothing else can be really trusted. And we're going to show you how we can actually chain the trust all the way to the software. But also the question is what part of the hardware can be trusted? Because unfortunately, there are newer attacks that shows that even the hardware cannot be trusted, or there are some bugs in the hardware and so on. And finally, the human factors plays a really, really important role in cybersecurity. So there could be mistakes during the design or the programming. So this is the bugs, or or there could be people that not following the protocols, right? So there is this email says that you have won $10,000. You click on it, and your system is exposed, right? But there is training saying that don't click on the links that you don't know, or don't answer phones that you don't know, and things like that. Right? So there are protocols you have to follow as an employee, as a user. Some people do and some people don't. Or sometimes the attack is so sophisticated that even if you think you're following the protocol, you don't, right? So that's another reason for this. Any questions here? All right, so that's number one principle. We need to know the threat model, all right? We need to make assumptions as accurate as possible and as comprehensive as possible. So that's number one we need to follow. The second thing about security is the overheads or trade-offs. Unfortunately, the security is not one problem that we need to solve. It's an interaction between things that we do for security with other aspects of the system. That's what's really prevents us to secure systems. So for example, you cannot use computers and be secure, right? So that's one way of doing it. You cannot use smart lock and then not be vulnerable to attacks to the smart lock, right? But because of the convenience, because of the other reasons, you want to use that. And this is the trade-off that you kind of play. You use more of these services and devices, but you make yourself more vulnerable to this attack. Second option is for the defense mechanisms that we're going to discuss in this course. There are different solutions that you can do, but unfortunately, these solutions come with an overhead. So for example, you can add this very sophisticated, for example, malware detection and add it to your cell phone. And it can be kind of guaranteeing that there's no attacks to your cell phone. But as a result, for example, your battery usage would be 50% less, right? So this is the trade-off the overhead that you have to play. And unfortunately, people mainly choosing convenience over security. So no one gonna buy that secure cell phone that has 50% less battery, lifetime. Because they're just kind of trained with this fact that battery is one of the key and more important metrics than maybe cybersecurity. So what happens is that whatever solutions that you come up with as a designer have to have this in mind, that the overheads cannot be more than some sort of thresholds. Depends on the scenario and depends on the metric. All right. So you cannot really build something that's so bulky and heavy or much more expensive and think that, okay, people will buy it. People not going to buy it. All right. And the solution has to be very convenient, user-friendly. 100, factor authentication is not a solution, right? So even two-factor authentication is not something that people really interested in, keep, using their cell phone in order to be able to log, right? People kind of resisting against it. These days, kind of becoming normal. But I remember the early days that people were kind of yelling at, the fact that you have to use their cell phone in order to log into your email, right? So the convenience is also another important factor. Is then when you are coming up with the solution for security, you have to be careful about that. So the main message here is that security itself is not an isolated problem. There are solutions already for it, but unfortunately, those solutions may not be an effective solution because of the other things that happens in the system. All right, any questions? And let me do one more final thing, and then we're gonna let you go. So we're gonna do multi-layer defense. So generally, the idea is that don't put all your eggs in the one basket kind of strategy. So we're not gonna do have a very sophisticated defense mechanism only at the software level. We're gonna have something at the software level. We're gonna have something at the operating system level. We're gonna have something at the hardware level, and so on and so forth. So the idea is that what we call defense at the layers, or defense in depth. We have multi-layers to defense, and the reason for that is that if the attacker finds a way of attacking one of these, there's still multiple layers of the system to be secure. And this is much more better than only having one sophisticated attack system and one of these layers, all right? So this is the standard these days, that you have a multi-layer defense instead of having only one or two layers of defense. And as I said, you usually call this defense in depth. All right. So we have multiple other things, but we're gonna pause here and then we're gonna talk about it on Thursday.
Thank you, Professor.
Yep.